Okay, so the first problem here says graph the system of inequalities. And so what we need to do is we need to figure out the slopes and y-intercepts of each of these lines and then graph them, figure out which side to shade, if it should be a dotted or a solid line, and then make sure we find the part that's shaded by all of the inequalities. So for this one, I need to get y by itself. To do that, I'm going to subtract x from both sides. And what I'm going to end up with is y is less than 10 minus x. And so I can identify that m is my slope, and that's -1. That's because there's this invisible 1 right here. It's multiplied by the x. The b is 10, and so that's my y-intercept. My y-intercept is 10, my slope is -1. So I'm going to go down 1 and then over 1, down 1 over 1, down 1 over 1. And I'm just going to follow that along the graph. Okay, this is a dotted line, and I know that it's dotted because it's not or equal to. So I can just kind of sketch my dotted line like that. This does not have to be perfect. Like that, that's good. Which side do I need to shade? Well, I'm gonna use a test point. Remember that my favorite test point is 0, 0. I'm gonna put in 0 and 0 for x and y. 0 plus 0 is 0. 0 is less than 10. That's a true statement, and so I'm gonna shade underneath the diagonal line that I just created. So I'm gonna shade all of this stuff down here. This does go on forever all the way over here, but there's a reason that I only gave you one part of the graph. So I'm just gonna shade, give me a second. Okay, cool. The next one says, all right, this is already written in y equals mx plus b. So I can just give I have my y-intercept is 2. I see that because it's right here. My slope is 1/3. So I'm gonna count up 1 over 3, up 1 over 3, up 1 over 3, etc. This is going to be a solid line. So I'm going to connect it with a solid line like that. I need to figure out which side to shade now. So I'm going to put in 0 and 0 for x and y, and I'm going to rewrite what I get out here. So I get 0 is greater than or equal to 1/3 times 0 plus 2. This says 0 is greater than or equal to 2. That's a false statement. 0, 0 is down here, and so I need to shade on the other side of the line from 0, 0. So that's all this stuff up here. So then I'm going to shade all of this stuff up here. Give me a second. There we go. Okay. The next one says, all right, well, my y-intercept is 2 again, but my slope is 3. And so this time I'm going to count up 3 over 1, up 3 over 1, up 3 over 1. And it's also a solid line because it's an or equal to, so I can use a solid line there. Like that. And then which side do I need to shade on that one? So I'm going to put in a test point. So put in 0 here and 0 here. So I get 0 is less than or equal to 2. That's a true statement. And so I'm going to shade on that side, the side where 0, 0 is. And so 0, 0 is over here on this one. Like that. After doing all of that work, now I need to identify what is the part of the graph that's shaded by all of the inequalities. And that's this part. It's dotted on this line right here. It's solid here, and it's solid here, and it's all of the stuff in between. So I can just kind of fill in that other stuff. It's kind of nice if you give me another color just to show me that you have finished your thinking, and that's like how you know that that's what the region is. Done. This next one is sort of a linear programming type of problem, and you're going to see one that's exactly like this when you're doing it by yourself. What we have here is we have a feasible region that I've already created for you, and I'm just making sure that you know how to check the vertices in for x and y and see what you get out. Remember that our points are written like this, x comma y, and so you can take your x value and put it in for the x here, take your y value and put it in for the y here. Let's do that for each of the points. They're already written there for me. So I put in 12 times 0 plus 8 times 6 I'm going to just do all of these really quick before I start evaluating. I'm just going to use my calculator for that too, by the way. Okay, so that's what I get. Now I just need to use my calculator for each of these. You can type this whole thing into Desmos just the way that you see it. And so that's how I'm going to do these problems. I'm going to just pause the video and then I'm going to write my answers in the value column. Okay, and what do I get here? I get 48, I get 24, I get 152, and I get 128.04. Depending on how we round this, we might end up just with 128. I really meant for this to be 6.667, and so we would be closer to 0.04, but that's okay. We'll just stick with that. Okay, what is the maximum value? Well, the maximum value is the biggest number, the greatest number, which is 152. The minimum value is the least value, which is 24. So I'm just going to label these with words also so that we make sure we remember. This is the minimum, and this is the maximum. Okay. On this problem, you have to do the exact same thing as the first one on this video. You have to graph the inequalities, find the part of the graph that is shaded by both regions. On this section, it's like the second question. I gave you the points, you put them into this objective function and find me the minimum and the maximum values.